Hello and welcome to today's physics class. Let's look at the concept of gravitational field. Alright, let's discuss the whole concept behind gravitational field, and then we'll look at the mathematical expression for gravitational field, and finally we'll look at Newton's law of universal gravitation. Let's start with definition of gravitational field. By definition, a gravitational field is a region in space under the influence of gravitation. So I'm saying that a gravitational field is a region in space under the influence of gravitation. Next up, you can also define gravitational field as can be defined as a region in space where the mass of a body experiences a gravitational force, in bracket pull. So when a body experiences gravitational force or pull, is said to be what the gravitational field. Alright, that's the definition for gravitational field. Having defined the concept behind gravitational field, there's a keyword there in definition. Observe the definition I gave you. I said a gravitational field is a region in space under the influence of gravitation. The question here is now, what is gravitation? Let's define the concept of gravitation. Let's define the concept of gravitation. By definition, gravitation is the force of attraction exerted by a body on all other bodies in the universe. A gravitational force exists between a body and all other bodies around it. So that's how you define a gravitation by definition. Alright, at this junction, let's look at one concept called Newton's law of universal gravitation. Let's discuss the concept behind Newton's law of universal gravitation. Alright, let's discuss the concept behind Newton's law of universal gravitation. Alright, let's discuss this a little bit. So let's discuss Newton's law of universal gravitation. Alright, put up please. Newton's law of universal gravitation states that the force of attraction between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance apart. I'm saying that Newton's law of universal gravitation states that the force of attraction between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance apart. That's how you state Newton's law of universal gravitation. At this junction, let's write out the mathematical expression for Newton's law of universal gravitation. Alright, from here please, mathematically, we said that Newton's law of universal gravitation says that the force of attraction between two masses is directly proportional to the product of the masses, right? And inversely proportional to what the square of this apart. So I'm saying that the force of attraction, that's F, capital F for force, between two masses is what there is proportional to the product of the masses, that's m1 times m2. All right, m1 times m2. Next up, it also said that, listen up please, listen, here's the concept. It says that the force of attraction between two masses is that proportional to the product of the masses, and that same force again, F, is inversely proportional to what? The square of this part. In this case here, the distance apart, the distance there is r. Please note that r represents the distance, while your m1, m2 represent the product of the masses, right? So call this man here, call it equation 1. Call this man here, call it equation 2. In broader sense, please, I could say, let's say I have m1 mass 1, let's say I have m2 mass 2, the center of the mass here and the center of the mass here. The distance between the two masses is given by r, and we said r is simply the what there, the distance apart. So I'm saying that the force of attraction F between the two masses, this and this, as you can see, right, is that proportional to what? The product of the masses, and this same force again is inversely proportional to the what? The square of this is apart, right, as I can see. All right, at this point here, I'll combine equation 1 and 2 together. So combine equation 1 and equation 2. What do I get? So I'm saying that this F is directly proportional to what? The product of the masses, that's m1 and m2. That's m1, m2. This same force here, this F is inversely proportional to what there? The square of distance apart, that's r squared. All right, well here. All right, from here, please multiply m1, m2 by 1. I'll have that force F is proportional to m1, m2 times 1. That's m1, m2 all over this man here. That's r squared. In mathematics, if I want to take off proportionality symbol, what do you do there? You introduce an equal to and a constant. I want to take off this man here. I will have to introduce an equal to and then a constant. All right, for me now, introducing an equal to, I'll have that F. Take off the symbol, becomes equal to, then a constant. In this case here, my constant is not K. Note that when it comes to Newton's law of universal gravitation, the constant there is capital G. So I'm saying that my constant is capital G. Next up, m1, m2 all over r squared. This becomes the formula for calculating the concept behind universal gravitation, or perhaps this formula behind Newton's law of universal gravitation. All right, keep this man pending. Note this formula for Newton's law of universal gravitation. All right, let's define term, please. We know that F here is force. Your m1, m2 are your masses. Why this r there is referred to as the distance, right? What of G? G is called, this capital G here is called universal gravitational constant. So this G is called universal gravitational constant, and the value for capital G is given as 6.67 times 10 to the power minus 11 in what? The SI unit for G is given as Newton meter square per kilogram square. So note that the constant for capital G is 6.67 times 10 to the power minus 11 Newton meter square per kilogram square. Alright, this is your constant for G. At this junction, why is it that my SI unit for capital G is Newton meter square per kilogram square? Why is it so? How do I get that SI unit? So look up, please. Look up. We said that from Newton's law of universal gravitational force, we said that F is equal to, I want to show you why the SI unit for capital G is actually Newton meter square per kilogram square. So we said from here F equal to capital G M1 M2 over R squared. In this case here, I'll try to make capital G the subject of formula here. So of course over 1, this times 1 is G M1 M2 in equal to F times R squared. That becomes F R squared. So it becomes your cross multiply concept. So I want to make G stand alone. Divide both sides by what? M1 M2. So divide by M1 M2. So have this man here, G M1 M2 over M1 M2 being equal to FR squared over M1 M2. What do you observe? This should cancel this. I'll now have that G, which signifies universal gravitational constant, is equal to FR squared all over M1 M2. Let's get the S sign in place. We know that the S sign for force is measured in Newton. Next up, R squared. We established that this R is what? The distance between M1 and M2. So distance is in meters. So it becomes meter squared all over M1 M2. Usually these are mass 1 and mass 2, and mass is of course measured in kilogram. So I'll have dot. If I'm having M1 M2, that becomes kilogram times kilogram. What do I have here? I'm saying that the SI unit of that place, the SI unit for capital G is given as Newton meter squared per kilogram square. So kilogram has kilogram square. I can write this in this form, and yet I can still write it as Newton meter square then kg to the power minus 2. This man and this man are still the same thing. So depend which one you want to use. So observe in this case here, I use slash. So if I don't use slash, I'll use minus 2 here. So this becomes how I got my constant SI unit, which signifies universal gravitational constant, as being what? Newton meter square per kilogram square. Alright, having said this, let's take just an example under this, and then we'll look at, in our next class, we'll look at relationship between capital G and small g. I know that you know that there's one thing of the parameter called small g. This small g is what all of us know, which is what? 9.81, or some people use 10 meter per second squared or use 9.81. So basically, small g is said to be, is called acceleration to the gravity. So in our next video, next classes, so in our next class, I'll be proving to you or showing you relationship between capital G and small g. But at this junction here, let's solve some past questions. All right, example 1 please. Let's take a question please. Welcome back. Let's take a problem under this concept here and we'll see how we can possibly evaluate the problem. It says that given two masses m1 and m2 such that m1 is equal to 2.74 times 10 to power 20 kilogram and m2 is equal to 4.31 times 10 to power 15 kilogram. All right, and separated by distance r, which is equal to 15 times 10 to power 4 meters, 4 kilometers. All right, find the force of attraction. So let's find force. We are asked to find force. So observe the question. Observe the given parameters, please. I'm given radius, I'm given r, which is distance. I'm given two masses. So that becomes a concept under what the universal gravitational, perhaps Newton's law of universal gravitation. So how do you solve this, please? It's easy as saying, so your task is to recall. So recall that we established that F is equal to capital G m1 m2 all over r squared. All right, let's input values here and get the exact value for the force of attraction between those two masses and separated by that distance apart. All right, from here I'll have that F is equal to capital G. We said that capital G is a constant known as gravitational, universal gravitational constant, and it's given as 6.6. So G is 6.67 times 10 to the power minus 11. Multiply this by what exactly? M1, M2. My M1 is of course 2.74 times 10 to the power 20 multiplied of course by M2. What's M2 there? That's 4.31 times 10 to the power 15. All right, I have this there. All over R. R is what there? This man, then is squared. So I have 1.5 times 10 to the power 4 over there, all squared. Here is the concept, please. Here's the concept. Actually, there's a mistake where I made a mistake. What's the mistake there? I shouldn't have go ahead and write this value this way. Why? Because we said that R is distance. And our distance here is in meters. I'm given this man in kilometer. So I have to convert kilometer to what there? To just meter. And we know that kilo is just 10 to the power 3. So in essence, I'll have this man as 1.5 times 10 to the power 4 times 10 to the power 3. Kilo is 10 to the power 3. Now I have my meters here. So in essence, I'm going to attach times 10 to the power 3. 3. So which signifies kilo. Then I'll have my square here. All right, I have this. So let's get F here. So if I'm to punch calculator, F is equal to, if I multiply this by this here, I shall have exactly 7.88 times 10 to the power 25 all over. If I'm to evaluate denominator, I should have about 2.25 times 10 to the power 20. Of course, from here, if I divide numerator by denominator there, what should I have there? All right, from here I'll have that my force F is equal to 350,222.22 Newton. This is my force of attraction between the two masses M1 and M2 separated by a distance apart, which is this. So this is my force of attraction. This is how I solve this particular question. So here's the task here. Here's the task. In the next video, right? In the next video, I'll try as much as possible to show you or to prove to you why capital G is equal to 6.67 times 10 to the power minus 11, and also I'll be showing you the relationship between capital G and small g. That is, I'll be showing you the relationship between universal gravitational constant and acceleration due to gravity much more later in our next video. Here's the concept here. To access that video, you have to be part of my JAM/WAEC candidate, right? A membership program where you can join to have access to that next class. So here's the concept here. I'll be showing you an icon behind the screen here. So that icon, try to click on join in my membership, in my channel generally. You see a join button. Click on join. You see WAEC/JAM class there. So you can click, you can purchase it. I think it's about 1,000 naira. Just buy the course, or perhaps buy the WAEC and JAM membership there. You have full access to over 200 plus video for chemistry, mathematics, and physics, right? So also do well to visit my website at www.danielabaraki.com/courses, so you can get my full tutorial videos and other science courses in my website. So do well to like this video, subscribe to my channel, leave a comment if you enjoyed this class, and also let us know which content you want us to create much more later. So I'm saying that to access our next class on the concept of relationship between capital G and small g, do well to purchase my membership under JAM and WAEC. It's not expensive, please. Not expensive, please. Do well to join my membership to have full access to over 200 plus videos. All right, see you in next class, and welcome to Excellence Link Academy.